All right, this video clip is going to explain the principle and the functioning of the load track 2 unit here. This is a load track 2, which is a load frame that can be used as load control or displacement control. So you can apply and maintain a load, and the load set here provides a feedback, or you can apply and maintain a constant displacement rate. Now, the first thing you're going to do, you're going to turn it on, and it has an internal CPU that is going to boot, and it's going to check everything here. You get the motor power, the CPU power, the network transmission, network reception. Everything has to be green, solid green on this side for the load frame to function properly. So this is all green, solid green, and I get a menu on the screen here. And so what I'm going to do here, I am going to show you how to move the platen up and down. That's basically all what you're going to be doing with this load frame, moving the platen up and down. All the other options here, you can read those options in the manual. You're never going to have to touch them unless you're going to change something, the motor or the gearing or something like that. And everything here is done through software, so nothing to worry about. The only thing that you have to keep in mind that this standard load frame comes with a 2,500 pound load cell, and all the calibration factors are for this particular load cell that is attached to this load frame. And if for whatever reason, for some special project, you need to change the load frame, a higher or lower capacity load frame, what you do, you just unscrew it here, and I'm not gonna, and take it out and unscrew it from the back. It connects to the first top connector, and then you can put your new load cell here. Once you change the load cell, then you'll have to change the calibration factor that corresponds to the new load cell. So what I'll do first, I just want to make sure that everything is working. So I go to monitor here. This is when I do it for the first time. I hit 1, then I got the sub menu here, which is a system. I can see my load, my travel, and some other information about limit switches. So if I push on my load cell like that, I should see about 20 pounds. So that means this is working. If I want to do further check, I can take my load cell, put it on the counter, and put a non-dead weight on it, and it should record that dead weight. The same thing with the displacement sensor here. If I move it up and down, I should see it registering accordingly. If I have a gauge block, I can insert a gauge block here, and it should move exactly the same thickness as my gauge block. Now, this shows limit switches are off. That means I have an upper limit switch and lower limit switch. The total travel of my platen is about 3 inches. That's more than plenty for all your applications. This load frame can test the maximum size triaxial diameter, 6-inch diameter by 12-inch in height. Typically, you take it to 15%. 15% of 12-inch, that's 1.8 inches. So that's a maximum, and we have 3 inches here. So should be plenty of travel that you have. You never have to worry about running out of travel or the displacement is gonna max out or anything like that. So if I move my platen all the way up, it will go about 3 inches, hit the upper limit switch and automatically stop, and I'll have a red blinking light. If I go down, it will do the same thing, and it will hit lower limit switch, and then the red LED will start to blink. Now, if I'm not sure what to do here, and I want to make sure I have enough travel, I will go into position here, and there's something called initialize. When I hit initialize, the platen is going to come down, hit the lower limit switch, and move up. So that gives me the full range. I actually recommend that you move the platen up about halfway so you are in the linear working range of the displacement sensor. Like right here is good. Now, as I said before, this load frame works in load control or displacement control. Load control is when you're doing consolidation, displacement control when you're doing triaxial and unconfined and CBR and other tests that require constant rate of displacement. If I want to move my crosshead here, what I do is I use the locking pins. So I move it up like that. Then I turn it 180 degrees and I take it out. It should come out real easy. And then I can take my positioning pins and I can slide it up or down. Now you notice there is a play here. That's why we have the locking pin that has its own pin here that will take out the play. So again, I put it and I move it 180 degrees and I let it go, and it should be all set now. So now if I want to move the platen up, I go to position, raise, enter. It's going to move all the way up until it hits the upper limit switch. I'm not going to wait here. It's going to take a few minutes. If I go lower, enter, it's going to go all the way down and until it hits limit switch, the lower limit switch. So now if you want to move it, when it moves up and down, you move at the maximum speed. If you want to control the speed, you want to move it very, very slowly. You go into the jog. So you hit 4. There's an arrow up, an arrow down. So if you want to go up, you hit the arrow up. Now it's going very, very slow. Now if you want to increase the speed, you hit 2 and up. And then you keep on hitting the arrow up. It will go faster, faster. You can even hit 3. And then it's going to hit the maximum speed. Now if you want it to go down, you hit the arrow down. And now it's reversing direction. It goes into a mode, so it starts to make a little music here. Now, if you're using jog, just get out of the jog at the end of that. That's the only menu that we do not might interfere with your test. So what you're doing here is basically raising, lowering, initializing sometimes, and jogging the platen. That's all what you're going to be using the manual option here. So now what I'm going to do, I'm just going to show you whatever I was doing here, I can do it to the computer. So we're going to the computer here, and there is a program called Diagnostics. This diagnostics program, I am going to click on diagnostics, and I have the diagnostic programs. They ask me which controller. That happened to be 65, and the default is 65. I go into view, panel. Now I have the exact panel that I have there, and they correspond, they're the same. So if I do raise, I hit 1, it's going to go up. This is going to change, it's the same thing, and I can go down. If I go to jog, so I can do the same thing. Either I can do it through the computer or I can do it manually with the keypad and the LCD. So this is all what you need to know about using the load frame. You move it up, you move it down, initialize it sometimes, and jog it in and out. All right, the soil that we're going to test in the triaxial typically has a cylindrical shape, and the height to diameter ratio is 2 to 2.5. And this is all coming from the ASTM standard. Now this soil is obtained from a certain depth from the ground, and typically you know where you have all that information. Then you take this soil and you set it up inside the triaxial cell. You have a bottom cap and a top cap. This is a top cap and the bottom cap that you see here, the black one. So you set the soil sample after you take all the measurements, the weight, the water content, all that information, and then you put the top cap on top. Where else it will go? And then you use a rubber membrane. You want to make sure that is a good one, that doesn't have any holes. You're going to find out when we talk about the triaxial that 90% of the problems running the triaxial are due to leaks. People don't spend a lot of time. They don't check things. This is your rubber membrane. What you're going to do, you're going to isolate the soil from the outside so you can control the outside and the inside. So the membrane is going to go inside this membrane stretcher. With all the experience I have, I've never been able to do this in one hand. So you have a membrane stretcher. So you put the membrane, you do the little vacuum. Remember, I use my mouth here, so next time. So the membrane now is stretched, and then you slide the membrane over, you release this small pressure there, and then you put O-rings on top and bottom. One O-ring on top, one O-ring on top, on the bottom. There's an O-ring groove here. Can you see it? So the O-ring is gonna sit in the groove. There's a groove at the bottom too. So you got your sample. We're gonna do a full video of that. And so say sample is inside the membrane, and you put the O-ring, and then you snap it, and then you move it down and it fits there. Now you have your sample and you do the same thing. You do the bottom one first and then the top one. You connect the drainage line that you see inside here, make sure everything is okay, then you run your test on the triaxial. What I'm doing now is I am going to run my triaxial. This video clip is going to deal with running a triaxial test. So I have my triaxial cell here. Obviously I need to move my my crosshead one notch up. So I center my triaxial cell. So there's a little gap here. I'm going to close that little gap. Not close it totally because the software does it automatically for you. Get as close as I can. My piston is locked. So I am close there. As I said, the software will close that gap. So I'll just show you that there is a gap here. So the piston is locked. there's water inside the cell. Now I have the valves here. There is a bottom drainage, so there are 2 drainage lines at the bottom and 2 drainage lines on top. So this is the top, this is the bottom, they're labeled here, and this is where the cell pressure, the outside cell, is being applied, and there's a vent too here. So first thing I'm going to do is I am going to connect my cell, and then I only need 2 flow pumps to run my triaxial, and this is going to connect to the bottom of the sample. So this video clip just shows you how I put my triaxial. I get it as close as I can. Everything is set here. Okay, this video clip now is going to talk in a similar way that we talked about the low track 2 unit. Is going to talk about the flow track, how this flow track works, and what you're going to do with it, and what's the principle and the keypad here and the functioning of that. Now, the flow pump here, the principle is that it just looks like a medical flow pump, where you have a piston inside a cylinder. The capacity of this flow pump is 250 cc's, which is about roughly the size of a can of a soda. And so that's how much volume of water you can hold inside. Now at the end of the cylinder, you have a pressure sensor that is mounted internally. The pressure sensor has a capacity of 200 psi. For people who are familiar with SI units, is about 1400 kPa. So for 200 psi, that's a pressure sensor that is mounted internally. And there are 2 valves at the end of the piston. This is what we call the supply valve, where we supply water, and the output of it is on the back, and it uses a 1/4-inch tubing. And on the front, there is an output valve. So there are 2 valves. There are solenoid valves that opens and closes automatically, so you don't have to worry about closing for doing end drain tests or opening for doing drain tests. As soon as you tell the test that is end drain, it will take it from beginning till the end with opening and closing valves automatically. So this is a full automated system. Now this flow pump, as I said, at the end we have a pressure sensor, so when it's pushing in or pushing out, is measuring the pressure inside the cylinder. Now the volume of water that comes out of the pump is measured indirectly by looking at the micro steps, the travel of the piston inside times the area of the piston. That gives you the volume change. So it automatically measures all the pressures, all the volumes, and those results are recorded too during the test from beginning till the end. So what you need to do now to make this flow pump work is that the connections to the flow pump, you have the power network, and then you have a supply. You need to provide a supply of water that preferably is de-aired water. So you get the 1/4-inch, you make sure you dip it inside, so you got your water supply. After certain use, you might want to change the water. Just you don't want to wait until it turns green, like the water over there. Then the output valve is here, and we have 1/8 of an inch tubing. And what we're going to do, this uses the same principle. As I said before, what you can do here is exactly same as doing it with the low track, and then whatever I can do here, I can do it through the computer interface. Now, I can open and close the valve manually. I can push water out or try to take water in manually here. what you're going to be doing is you're going to make sure you saturate the lines so you don't have air in the line when you run the test, that you're going to be putting air in your sample. So what you're going to do here is, first, you want to make sure that your pump is filled with water. So you go into the menu and position. Remember, there was a position where you raise the platen or you lower the platen. Here you're not raising, you're pushing the piston in or you're pulling the piston out. So when you're pulling the piston, that means you're generating pressure and you're pushing water out. Either you can push the water out of the supply or you can push it out of the output. You decide that. We're going to be pushing it through the output here so we can fill in all this line here. The first thing, we want to make sure that there is water. So I go into position here. If I go first to monitor system, that tells me is 50% full. What I'm going to do here, I'm going to pretend I'm starting from scratch. I go to 2, position, and I said I'm going to empty because I don't know what's inside. So I'm going to empty all the water and then fill it. So I go to empty, I hit 1, I do enter, and it says flow out. And there's water coming out from the tube because there was water. So the water is coming out, so it's emptying. Now it's going to go all the way until it hit limit switch, empty, and it will stop. So it stopped. I put it back in here, and it hit limit switch. Now what I'm going to do, I'm going to go to escape, and I do fill. Now it's filling. You notice there's a difference in the sound. When it's pushing, it was creating a positive pressure. And it's pushing water as fast as it can, it's all positive pressure. When it's filling, it's creating a vacuum inside. And if it's too much vacuum, that can damage the pump. So there's a feedback here. It keeps tracking, monitors the vacuum, and it's going as slowly as it can. So you cannot control the speed of filling the pump because this is a safety measure to prevent any what is called cavitation problems that might occur with vacuum. So now it's filling the pump, and it will fill it all the way until it hit limit switch. We don't need to fill it all the way. We can stop it at 30%, 50%. We don't need all that much water. But if I want to stop it, I do escape, and it will stop. I can look how much water is here. It's about 13.7%. Another way of filling the pump at 50% is called initialize. Here on the low track, when you initialize, the piston goes all the way down, hit the limit switch, and goes up, so it gives you the full range. Initialize here, what it does, if I hit initialize, it will empty the pump, and it will fill it to halfway, 50%. Why is that? Because when you run a triaxial, sometimes the soil, if it's spongy, wet, it will give out water when you put pressure on it. So you want to make sure there is room in the pump to take in water. Sometimes, if the sample is totally dry, you're pushing water inside. So you want to start with enough water so you can saturate your sample. So by default, when you do initialize of this pump, I can initialize all this pump here, same way. It will empty, clean up all that, and it comes back to 50%. Now this is manual mode. On the computer, when you run a triaxial, before it runs the test, it will ask you if you would like to initialize the pump to make sure you have enough water so the test will be completed successfully. Now, you do have control how much water you want to fill in the pumps. You can say 75%, 50%, 60, any value. Based on what? Based on the size of the sample and its initial degree of saturation. If you're not sure, just put 50%. Now the water, you see flow in, flow in, flow in. That means it's sucking water out. You want to make sure that those lines are all the way at the bottom and you're not sucking air inside the pump. That can create a problem later on. You don't want to be pushing air in your sample when you're trying to saturate it. But right now what I'm going to do, I want to saturate this line. So what I do is I go into control valves, number 5, menu, and I'm going to open the output valve. You see this valve here, output valve? I hit 1, it will open. Now I have the supply valve open and the output valve. Because this one is higher than this one here, I can wait. I can go down here and let it drip. And it will eventually, water will go from this reservoir water, go to the pump, and come out. Here, it will start to drip here. But I don't have time to do that, so what I'm going to do, I'm going to push it. So what I do is I'm going to close the supply valve, which is number 4 here. And I'm going to escape and do jog and hit flow out. And then I wait for the water to come out. And with all the air that is inside here. See, there's water coming out. So in my line, I'm saturating the line using the jog. So I can stop it now to escape the jog. So my line is saturated with water. My output valve is open. The water is not going to be dripping because there's only one valve open. If I open the supply valve now, it will start to drip out. But I'm not going to do that. So there's water inside. I'll make sure that there's no air trapped here, which looks good here. Since my line is full of water, and I can go to monitor system, I can see my pressure here, and if I raise this pressure here, if I raise it about 28 inches, I see about 1 psi. So that's another way of checking that the sensor is calibrated correctly. In this video clip, I'm going to show you how you set the 0 values for the sensors that they are involved with the triaxial test. Now when you run a triaxial test, you have a frame that has 2 sensors. One is a load cell and one is a displacement sensor. The load cell will measure the vertical or the axial stress on the sample. Displacement is deformation of the sample. Now the displacement, you do not have to zero it. The software automatically zeroes your displacement sensor. So nothing to worry about. The displacement sensor is mounted underneath here and is set, and you forget about that. Now the load cell can be zeroed by changing the offset value to the value that you read when there is no load. So what you do here, you go into the software, you load your template file. So you go to File, load your template here. Then you go into View, System. You look at the load cell, you see it's reading 32736 in terms of analog reading. And I know that there is no load on it. It should be reading 0 because it's not touching anything, just hanging in the air. So what I do, I go into Calibrate, Summary, and Load, and I override that offset by typing 32737. That's the value that is here. Then I say Apply, Download. It will download it there, so they will be in sync between the PC and the load frame. I do OK. Now I see my load cell is reading 0, fluctuating about plus minus 0.13. pounds. That's the resolution that I get from my 2,500 pound load cell is about 0.13 pounds. Now, my load cell is 0. The displacement, I do not have to worry about it. Now, the cell pressure and the sample pressure that they're coming from the flow pump, we have cell pressure and sample pressure. Now, the 0 for that right now is reading about something 0.5 psi for the cell pressure and about 0.3 for the sample pressure. The standard says is the actual 0 for your pressure is mid-height of the sample. So right now what we have the two flow pump with the output valves open. So the output valves are open, lines are filled with water, and then what I'll do, I'll go right here and I hold them halfway, mid-height of the sample. So I hold that, make sure there's no air trapped here. So this is my level of water, right halfway. And I'll hold it here. I got Steve graciously volunteered to hold it for that. Now I go back here and I look at my cell pressure and my sample pressure. I go back to the calibration summary. I go to the cell pressure and I change my offset to the one that I read now for mid-height of the sample, 32862. I do apply, download, now it's 0. And I do the same thing with the sample pressure, is 32908. I do apply, download, okay. Now, all my sensors are zeroed. I'm ready to run a triaxial test, but this is what is important, that you zero your pressure at the beginning of the test, because the height of the sample is going to vary, and also the platen position might vary a little bit. So you might have a small variation that you want to just check it, and that's a good way also check that everything is working. And that's how you zero your sensor prior to running your test. So what we have done is we had bled the lines, make sure there's no air trapped. And even if we find out there is some air trap, when we run the test, we can still get rid of the air inside. And we zero our sensors, and we're about ready to run our triaxial test. Okay, we're going to be running for demonstration a triaxial test. The triaxial test that we selected to run is the most common, the most popular test, is a consolidated isotropically Undrained with pore pressure measurement compression test. In short, they call it CU test, Consolidated Undrained. And so we're going to run this test. Now, this triaxial test is an involved test. It has a different phases, and within the phases, there could be different steps. The three major phases in the triaxial are the back pressure saturation. So we want to make sure that the sample is fully saturated. And the second phase, or the phase that follows the back pressure saturation, is the consolidation. So the sample needs to be consolidated to the effective stress that exists in the ground. That's for the first point. And the third phase is the shear phase, where we're going to increase the vertical load at constant rate of displacement, and we're going to be measuring the excess pore pressure, the load, and the deformation. So this test has multiple phases in it. And now, traditionally and manually, people used to do it by hand, where they do the back pressure saturation using a manual panel with all kinds of manifolds and valves and burettes to keep track of volumes and pressures. After the saturation phase, they do the consolidation and the shear. The system here that you have, it does it all automatically. It goes from one phase to the next phase till the end of the test automatically, based on the criteria that you have set in your software, or you can just use the default criteria. Okay? Thank you. Okay, we're going to run a triaxial, CU triaxial test. We have our sample is ready, our lines are bled, and what I'm going to do is I go into the software called Triaxial, I double click on that. Same thing as I did with my consolidation, you must always go to File and load the template file. So I got my template file here, and you need to fill in all this information. The most critical is the diameter and the height of the sample. So I am filling the information as best as I can. Water content, read table here, test parameters. So all this information, there are default information here. Okay, so all this information here, what I do first, I go to View, System Monitor, make sure that everything looks good. There communication between the hardware here and the software, which I can see it here. Next, as I said, lines were bled, and what I do, I connect my cell pressure and my sample pressure. Now, something very important here I need to mention is you have all these valves on the triaxial. Now the software does not know what's going on with this valve. So as a default, you have all these valves open except this one here. This one is open, and what we can do, we can use it to bleed or get rid of any air that is trapped here. So the first thing we can do is we can bleed the inside lines in the triaxial before we run our test. Okay, this video clip is going to explain how we're going to get rid of the air bubbles that they're inside the internal tubes here. So what we have here on the triaxial, we have the bottom and the top drainage lines, and they're bridged together with this line here. So I can push water from the bottom and it comes out through the bridge line, and then it comes out until the end here. So what I'm going to do, I'm going to push some water from my bottom pressure until I see it coming out from the top. So I use the same technique here, which I have the output valve open, and I'm going to push flow out, and I can see the water is going here. It's going to go to the line here, come out this way, and eventually it's going to start coming out from this line here. So now it's just pushing air that is in the lines. I can see the air, and if I put it here, you can see it bubbling. Now here's the water coming out. So what is this water coming? What's the path of the water that is coming out? I'm pushing water from the pump through the output valve. The water is going in this line, going to the bottom of the sample, coming out from the bottom of the sample. There's a bridge valve here. It's going to the top, goes to the top, and it's going to come out from the last one. Now I have all the lines inside, outside here. They're all bled. There's water coming out, and I can just stop it. When I stop it, what I do is I close this valve. This is the only valve that needs to be closed for the triaxial. All these valves are open. So the valves are open. The valve control is done here to the software. The software does not know what triaxial cell you're using. You could be using any triaxial cell. Maybe it doesn't have valves. It does have valve. So by default, valve number 1, 2, and 3 open all the time for the triaxial. This one is closed. This one you only use it if you see air bubble, you want to get rid of it, then you can get rid of it. So that is the default position of the valves. And now we are really ready to run our triaxial. Thank you. Okay, we have get rid of all the air bubbles in the line, the outside, the inside, the internal lines. So everything is bled, everything is ready to go. That's my triaxial cell. As I mentioned in the previous video clip, the valves, they have to be open. The piston here is locked. The software is going to ask me to unlock the piston. The last valve here is closed. That's the only one that is closed. And it will remain closed during the duration of the triaxial test. So I have loaded my software and a template file. Everything looks good. I go into System Monitor, make sure that everything is on. There's a communication here. And I go to my project. I fill in all the information I need to, like the date, when this test is run, location, the tester, the checker, specimen information, water content, how I'm going to read the data, how I'm going to run the test, the parameters involved in the test. Now I have what is called initialization phase, which is something is not in the ASTM, but what I'm doing with the initialization phase is I'm applying small stresses on the sample to keep it together. And also the initialization phase actually has many benefits here. Now the first thing is to keep the sample together. Second one is make sure that everything is working properly before I run the full test, so I don't mess up my sample or bust the sample. Sometimes you only have one sample that you're going to test, and some of the samples are really expensive. If you bring the sample on offshore, it might cost $10,000 to get the sample, so you only have one shot. And this initialization is very important. So if the system cannot maintain 1 or 2 psi small pressure, then it won't maintain bigger ones. So initialization, I put a vertical stress, a horizontal stress, and a sample pressure. And also, more importantly, this is where I can detect if there is a leak. If there is a leak, and as I mentioned before, 90% of the problems with the triaxial are leak related. And this is where I can catch it at the beginning. If I put 1 psi difference between the outside